I feel it did on team. Huh? Huh?
So for the exam right here, test, if you know that it's or I'm going to do no, but I'm just playing back. If you know that it's decreasing, you don't look at all the steps to like put it on the number line.
How do you know it's decreasing?
Because like if you look at the equation, you can see that the bottom is increasing faster than the top.
Well, to be very particular about this, you have to prove it.
Okay.
You cannot just say, I feel like it's decreasing. It's just not how it works. You cannot say, hey, I become a doctor and I say, I feel like you have a certain type of disease that, yeah, because I feel like it. You have to provide me a proof why.
Say that the numerator is decreasing while the denominator is increasing.
You have to follow what I said. It's decreasing. There's two ways to prove it.
How do I do that?
You can, then you don't know how to do n plus 1. It's probably hard to do n plus 1 in this case. It's probably easier to do a derivative. To tell you, like, if you're up to this point and you cannot do quotient rule, that's bad. You know it's decreasing, but you still have to prove to me it's decreasing. So first one's very easy to prove. Since the pi is greater than 1, then it's automatically converged. And due to p series, and that's the way you should write it. You should say since the pi is greater than 1.
Yesterday, when I do number line, like, what is the exact thing that I do?
You're gonna do from 0. You're gonna do from, usually it's from 1 to infinite, because you don't need to worry about negative version of it.
Is there anything that I basically have to write, or if I was like if I do the number line, does it automatically go, or do I have to write it decreasing from 1 to
You have to prove that's decreasing. I'm pretty sure you can do either way. Yeah. All right, so okay, so this is the f of x, right? So you can do divergence test, and if a divergent test, it goes to 0. So go to 0 doesn't mean it's anything. It just means it's possible converge and it's possible diverge. So if I say f of x is equal to e to the 1 over x, and then this is the x squared, so f prime of x is equal to low d high, which is e to the 1 over x times what? Negative 1 over x squared, right? because this is x to the negative 1, so it'll be negative 1 over x squared. Is that okay? Minus high d low, which is 2x, over x to the 4th. We know x to the 4th is always positive, so we don't need to worry about that part. But we can cancel this, so that's going to be e to the 1 over x. I can factor out. That's going to be minus 1. Minus 1 plus minus 2x. Thank you. And that's equal to x to the 4th. I can factor out a negative sign. Now, since this bottom, x to the 4th, we only worry about going from 0 and up. We don't have to worry about negative side because because the series start from 1 to infinite, right? So then this is gonna be positive, and this part is gonna give you positive, positive. So this is positive, positive. Sorry, positive, positive, and negative. So it's negative here, decreasing. So it's always f prime of x is always decreasing when x is greater than 0. So then you just have to say integrate, and then e to the 1 over x squared from 1 to infinity. What's your final answer? No.
I got
E minus 1's correct.
So does that mean that that doesn't mean that the series converges to e minus 1, right?
No, but it does tell you to converge.
How would you find what the series
What?
How would you find?
You can. No. But you did provide a proof that it's converged.
Okay, so that's all you have to. You just have to.
So this one's gonna be integration of e to the 1 over x squared dx 1 to infinity. That's gonna be b a 1 e to the u. So it'll be negative e to the u du. You ready? Okay, so what does this say? This is gonna converge, right? If you have e minus 1, it's converged. This does not mean that it's going to converge to e minus 1. It just says it's converged because the integral test, it come out to a certain value. If it come out value, if it come out as infinity, then you will have a diverge. If it come out value, that means your series is somewhere around there, but it's not accurate, but it's enough to prove you it's converged. And then you're done. However, there are other situations that this one cannot work. So at this particular today we're going to talk about comparison tests. Yeah. So it's also known as a direct comparison test. Did we already start out yesterday? No? Okay, for 0, less than a to the n is less than to b to the n. So there are there's two type of sequence here. Now, if a series, so basically this has to be the first situations, right? One series is less than the other series. Now, this one's very easy to understand. So basically, we're saying if it's infinity, n equal to 1 to infinity of b to the n, it's converge. Then what do you think n equal to 1 to infinity of a to the n? It will also be converge. Because it's less than converge. If you less than converge, it has to be converge. Does that make sense? If it's less than converge, it has to be converge. Does this make sense? Because that just says, let's just say Khrushchev is dumb. And I am less than Khrushchev. I'm less intelligent than Khrushchev. Therefore, I must be dumb as well. Huh? Yeah. If a Khrushchev is dumb and I'm less than Khrushchev, I'm less intelligent than Khrushchev. That proves me I must be dumb. Sorry, Khrushchev. He sacrificed for the team twice. All right. Sorry. Okay, so the second situation is this. If, remember, this is the first condition. The condition is it has to be this, right? It has to be this situation. It has to be Bn and An, and An's less than Bn, and it has to be that way. If that's true, then the first statement will be true. Now, this one's actually interesting. It's kind of confusing on the second one. So a equal to 1 to infinity. If An is diverge, then summation of n equal to 1 to infinity of An must be diverged as well. Oh, sorry, the second one's Bn.
On the first, yeah, it's a equals 1. N equals 1.
N equal to 1. Okay, so if the smaller series is diverged, the bigger series must be diverged.
You mean if the bigger is oh. Yeah, what would be like the comparison?
Comparison. Yeah.
He is less smart than Christian, but he's smart than Christian. Okay, you just made it.
Okay, so in layman's term, I know you guys like Professor Lehner. If I'm good looking, and Professor Lehner is better looking than me, I know some of you guys are very thirsty. Then Professor Lehner must be even more good looking. So it has to be good looking because he's already better looking than me. And if I categorize I'm good looking, then he must be good looking. That's pretty much it. I don't know.
Does it go the other way? Like if you know his BN diverges,
Bn's diverge, then an does a can be converge or diverge.
Because we don't know how much it's greater than or less than.
Yes, it doesn't go the other way. That's a great question.
If the outside is big, we don't know if the inside is big. But if the inside is big, then the outside is big.
There's too much thought.
Okay, so
Mr. Yang, can you teach infinity?
okay, so what we're gonna do is we're gonna determine is this converge or diverge. So n equal to 1, infinity, 1 over 2 plus 3 to the n. We're gonna ask yourself, hey, are this diverge or converge? And the best way is do some type of comparison. So yeah, not P series in this case. I won't do P series because this is not P series qualified. However, which two series I want to compare with? That's gonna be a better question. So which two series I want to compare with? That's more important. So we obviously we have this series, but what does this directly compare to? Like which one you want to compare to? The easy one. Which one you want to compare to? Like you know of. No. Something that's there that you might want to,
Just
you know,
3 to the n?
huh?
Just 3 to the n?
Closer. 1 over 3 to the n. Why you want to compare to 1 to 3n? Because you think about it, right? 1 over 3n is something that we know. What kind of series is that? Not P series. No, it looks almost like P series, but it's not P series. Geometric.
She said it like 5 times and you still got it.
Okay. Yeah, you should, Corbin.
Yeah, I know. I'm sorry.
You are.
Okay.
I'm gonna use series to determine how you are.
You need to learn it.
You can't project your own senses and all maybe.
Okay, so why is that? Why is it you compare with? So I'm gonna use this line to compare with. So compare with 1 over 3n, because usually I can cover one part up and just say, hey, let's compare to that. And there's a reason why we compare to that. 1 over 3n, this one is not n to the p, if you pay attention. This one is gonna be n equal to 1 to infinity, 1 over 3n. Can I rewrite as infinity summation n equal to 1, 1 over 3 to the n?
Yes.
Okay, so if you have, because 1 to the n also is 1 to the n is just going to be 1, and 3 to the n, so I can put it that. So this is a common ratio. Common ratio. Does that make sense? And it's a common ratio that's going to be, you know, it's going to be the first term divided by 1 minus 1 over third. And you can actually find out what it converges to, because I'm going to say this again. Geometric series is only one you can find out where it's converged to, not any other test. Does that make sense? Because you actually have formula of a over 1 minus r. Am I going too fast? So if this is a 1 over 3 is less than 1, your common ratio is less than 1, so geometric series has to be converged. So geometric series says converge. Shit, what are you laughing about? Okay. Now, here's the thing. 1 over 2 plus 3n is bigger than 1 over 3n or it's smaller?
It's bigger. Bigger. You went the wrong way.
I'm going to say that again. 1 over 2 plus 3n is greater than or less than 1 over 3n. If you don't know, plug in a number. Shh. If you don't know, plug in number. For example, n is equal to 1. If n equal to 1, 1 over 5 is greater than 1 over 3 or less than 1 over 3. Assume, let's say assume n equal to 1. Right? So that's going to be 1 over 5 less than 1 over 3. Does that make sense? It's less than. So 1 over 2 plus 3 to the n is less than 1 over 3 to the n. Why? Because this is already converged and this less than converged, so it has to converge according to direct comparison test. Ethan, does that make sense?
Yeah.
You said it wrong at first.
Yeah, you did. At this point, I don't remember what I said. I think I've confused myself in talking.
Because you think about it, when numerator in this particular part, numerator is bigger, but numerator is bigger is actually lesser than whatever. Does that make sense?
Yeah.
You can plug in 2. Plug in 2, see, if assume n equal to 2, right? Let's just say assume n equal to 2. Then that's going to be 1 over 9 is less than 1 over 9 plus 2 because this one has a greater denominator, so it has to be lesser. Ken, are you confused? Okay. So if this is converge, this summation n equal to 1 to infinity 1 over